Good morning. This lesson is for my Trig-Precalc class, but before I get started, I want to say I hope that everyone's doing all right out there. I'm not sure how I'm going to title this lesson, but I'm going to title it how I title it in the title. But what I am sure of is my one goal for this lesson. And my first and only goal is going to be drawing quadratics so we can complete the square. And this lesson is going to be about how to deal with negative b values and or c values. So this is the second lesson in this quadratic series, but this second lesson deals specifically with the completing the square process. Now, I'd like to point out that for every problem in these lessons, the a value, which is the leading coefficient, will be 1. Okay. I'm not going to get into what to do when a is not 1, but actually just divide away the number, and then you go about the process, but I'm not going to go too much further. But let me just summarize what we're going to do here. So we saw in the previous lesson that we start by cutting the b value in half. Same here. So I'm going to have to cut that in half, and cut that in half, and cut that in half. But there's an implication about the little squares, which hopefully it becomes very apparent by working through some examples. So I think maybe for this lesson, it's just best to jump right in and do examples. So I have a negative b value, positive c, negative b value, negative c, and negative b value, positive c. And I think that I'm covering most cases for situations that can occur, that I want to occur, because there's still other things that can occur. All right, so again, I'm going to start to try and represent my quadratic as a square. So I'm going to draw the large x squared, and off to the side, I'm going to have 3 negative x's. 3 negative x's. Because that's half of 6x, and I'm going to have 3 negative x's off of this side. So the side length of the width is x minus 3. The side length of the length is x minus 3. And negative 1s times negative 1s are positive 1s. So all these values have to be positive because, again, negative 1 times negative 1. Negative 1 times negative 1. So there's going to be a bunch of positive 1s. Now, we're going to need, it looks like, 9 little 1s. But we actually have 5 little 1s. So we have this many positive 1s. 5. And in order to complete the square, I need to add 4 more little 1s. Okay. 4 more little guys. So I need 1, 2, 3, 4. So I need to add 4 more little squares to this. Now I'm going to get x squared minus 6x plus 9. And that's equal to 4. So in order for me to complete the square, I needed 4 more little squares. I know my side length is x minus 3 times x minus 3. And again, this is us making this into a square, so we can exploit the fact that we're going to get x minus 3 squared. All right, and it's a lot easier to get rid of a square on the outside of the parentheses sometimes than inside a quadratic. So x minus 3 squared is equal to 4, and we go about solving this by square rooting both sides. So the square root the left side, square root the right side, the square and the square root cancel each other out, and I'm left with x minus 3, and that's equal to plus or minus 2. Let's add the 3 to both sides. All right. And let's see, that cancels out. X is equal to plus 3 plus 2, that's 5. Plus 3 minus 2, that's 1. So my roots for this one, this is a root or a 0, is going to be 5 or 1. So if I plug in either of those values into that, I'm going to get 0. So that's what it looks like when I have to add some positive ones. All right, let's look at the next one. X squared minus 8x minus 2. Now, I am intentionally keeping the b value small because I don't want to spend all this time drawing, but the idea works for larger values. All right, let me mark that off, give myself some space, and start to draw this. There my x squared minus 4x's. It's not going to be very straight. I can see this is already off. Minus 4x's. and I get the minus 4 and the minus 4 by cutting that in half. My side lengths are going to be x minus 4 and x minus 4 again. Now, I have two negative squares, but I can't have negative squares in here because I have a negative 1 and a negative 1. These are always going to be positive 1s. So not only do I have to have 16 little squares to complete the square, all right, I need 16 little ones to get to the square that I'm trying to build. I need 16 little squares, but I'm in a deficit of 2 squares. So not only do I need 16, I need to cancel out that 2. So this is why in this situation, I'm actually going to add 18 squares. This 18 gets rid of that 2 and it gets me to what I want. Now, you could also write it like this. I need to get rid of the 2 squares and I need my 16 squares. I need to get rid of my 2 squares and I need to get to 16 squares. And this might be a little easier way for you to figure out or how to get the value that you need to add or subtract to complete the squares. All right, so now we can move forward with the problem because now we know what we need to complete the square. I'm now going to get, let's see here, x squared minus 8x plus 16, and that's equal to 33, and 16 gets me to 49. But the side lengths of x squared minus 8x plus 16 are going to be x minus 4 and x minus 4. But again, we're exploiting the fact that we have identical side lengths, so that means now I have x minus 4 squared is equal to 49. And again, when I get my square on the outside of a parenthesis, it's very simple to deal with. And we square root both sides. The square root and the square cancel each other out. And now I'm left with x minus 4 is equal to plus or minus 7, because 7 is the square root of 49. I can finish solving this by adding 4 to both sides. All right, so here's my x is equal to 4 and 7, that gets me to 11. And 4 take away 7, that gets me to negative 3. So these are the values of x that if I plug in this, I will get a height of 30. All right, is that right? Yeah. 9, 24, 30. Yeah, that works. All right, so this will get me to a height of 30. All right, last example. So this example, I had two negative squares, and again, I had to overcome that with positive squares, extra positive squares. All right, so let's see what we have here. I have x squared minus 4x plus 6, so I'm going to try and draw this as a square. Now remember, I cut that value in half, and I'm going to get x squared. Oh, this one's nice because I don't have to draw that many. There's my negative x, my negative x. I find most x's are negative. All right, so this is my length of x minus 1, minus 1, x minus 1, x minus 1. So my side lengths are going to be x minus 2. Now I need to have 4 little squares. But guess what? I have 6. I have 6 little squares. So that means, like before, I have too many. So what I'm going to have to do is I'm going to have to get rid of some of these. I'm going to have to cut some of these out. So these squares are going to go, and the way that I'm going to get rid of them is I have to take away 2 squares. So minus 2, minus 2. I'm going to write the answer down here so I don't go off the screen. I'm going to double check, because I hate having to re-record these things because I went off the screen. Oh, I got plenty of room. Wonderful. All right, so now I'm going to get x squared minus 4x plus 4. And that's equal now to 16. But again, remember, we know our side lengths is x minus 2 and x minus 2. And we're exploring the fact that they're identical, because when they're identical, we can say it's x minus 2 squared, and that's equal to 16. And just like before, we can square root both sides. And here I get x minus 2 because the square root and the square cancel out. X minus 2 equals plus or minus 4. Let's add that 2 to both sides. And we get x is equal to 2 and 4 is going to get me to 6, and 2 minus 4 is going to get me to negative 2. So these are the values that will get me to a height of 18 when I plug into that quadratic. So I'm going to go ahead and end this here. Again, I thought this would be a better lesson just to work through using examples. Hopefully this makes sense. I think that I hit what I wanted to hit with this lesson. Yeah, I did. There's a couple more situations that the following lessons will be about, but again, hopefully you understand why this is called completing the square. And it's really kind of a beautiful way to go about solving quadratics that might not be so obvious. And we'll see what happens when the problems get to be a little bit more difficult. And maybe I can convince you that it's actually better than the quadratic formula. So I'm going to go ahead and end this lesson here. Again, I hope everyone is doing all right out there. Have a great day, everybody. That's it. Bye-bye.